Chakras exist, but they are not what you think. You may be familiar with the concept of chakras from Indian religions as sort of glowing orbs that are located along the body with some kind of spiritual energy that is supposedly not detectable by current technologies. There is often a debate where this view clashes with the Western biomedical view of the body and organs, and the way that materialist science has classified the body and all its functions and pathologies. In order to talk about this debate, I first want to draw analogies to a familiar concept: light, and specifically the light spectrum. In nature, there is what is called a prism effect, where a bundle of light can be split into a rainbow. This can happen through droplets of water in the air or through crystal prisms, but the point is that this is something we can see. We can also measure it, the individual wavelengths of each color. There is also a distinct qualitative aspect to what it looks like. This is what we call colors. In English, there are the following distinctions of colors: purple, blue, green, yellow, orange, and red. But something you might not know is that other languages have different ways of basically cutting the cake or splitting the light spectrum into color words. Shona has 4. Tamil has 5. Dani only has 2. The point is that different cultures and languages have different ways of passing the experience of color. There is the natural layer of the light spectrum itself, and then there is the cultural layer, how we talk about these things, how we categorize them, so that we can talk about these phenomena with other people. So, looking at these colors, what words might you use to describe them in English? You probably thought of green and blue as 2 rough categories. But if you speak Russian, you might have thought that these 2 blue colors are actually 2 different colors, not 2 shades of the same one. They are sini and goluboy, 2 different Russian color names for what English calls dark blue and light blue. If you speak Japanese, you might not have thought of more than one word at all to describe these colors. Namely, ao can refer to any of these 4 distinct colors. What about this spectrum? In English, we might say that it is roughly divided into blue and purple. But a Tikuna speaker might say that the majority of this is called jaux, and only a small part that is truly purple is called dao. In the Bulare language, it is the other way around. Only the very end of the blue spectrum is called iluji, and the rest is called lerem. In the Didinia language, these are thought of as 3 separate color categories, roughly divided into sulak, holia, and rega. Evolutionarily, languages have a tendency to develop color words in a specific order. The first color words are usually black and white, distinguishing light from darkness. The next word to enter a language is almost always red, because many salient and relevant phenomena are red and therefore important to talk about. Next, either yellow or green is added. After that, almost unanimously, a word for blue appears. Only later, in any order, do the colors purple, orange, pink, and grey enter the language. Now let's move to a different sensory organ: taste. We now know that there are roughly 5 taste categories, namely bitter, sour, salt, sweet, and umami. For a long time, however, we did not really think of umami as a taste. Regardless of this, the actual taste-sensing cells in our bodies were always divided into 5 types, even when we did not yet have a specific name for the 5th one. Only later did English adopt the Japanese word umami, which roughly translates to savory. Before that, we simply did not consider it a primary taste. Another example is sound. In different languages, timbre refers to the quality of a sound, and it is usually talked about in metaphorical terms using adjectives that refer to something non-auditory, something concrete or physical. For example, strong, dark, clean, round, smooth, bright, piercing, tonal, nasal. All of these words are ways to describe the quality of a sound. Furthermore, in music, there are different ways to construct musical scales. In the West, we commonly use the major scale, which contains 7 notes. In many Asian cultures, however, a scale called the pentatonic scale is common, which uses only 5 of the 7 notes of the major scale. Another example is the Hungarian scale, which also has 7 notes, but with different distances between them, giving it a very different sound from the standard Western scale. Arabic music uses maqamat, which include what are called half-flat notes, pitches that fall halfway between the semitones normally used in Western music. In Indian classical music, there are many different scales known as ragas that also use various intervals which fall between the standard 12 semitones in the Western octave.
Sari ga ma pa da ni sa, sa ni da pa ma ga ri sa.
But if we really think about it, pitches, sound pitches, musical notes, are really just different points along a continuous spectrum of sound, a range of sound frequencies. This becomes very clear with an instrument such as a trombone, which can play glissandos, where all of the intervals between notes are played. In that case, there is no longer a specific scale being played, other than a continuous slide from one pitch to the next. Another example is emotions. Many languages talk about emotions, and this is The Wheel of Emotions by the psychologist Plutchik, who hypothesized that different emotions are different ends of a spectrum, involving approaching or retreating from a stimulus, combined with negative or positive tone. These categories basically codify different ways in which an organism can respond to its environment. Again, emotions are not visible. This diagram is just a way to visualize them. Emotions are felt, subjective, and cannot be shared or empirically measured or verified in any other way than asking a person what emotion they are feeling and then describing it using language. In a similar way, modern neuroscience correlates different brain regions with specific cognitive functions. This image shows how different functions map onto different regions of the brain. Again, it is not the case that if you look at this brain or dissect it, you will literally find speech or taste or emotion, or thinking, or moving, or touching, or hearing inside specific locations. None of that is the case. These locations correlate with these activities, but they cannot be reduced to them. So these are all different ways in which states of mind, like sensory perceptions or emotions, or processes like thinking or information processing, have different words to describe them, roughly speaking. Even though they are not always objectively real in the same way, there is also a difference between describing something in the third person versus the first person. All of the aforementioned examples are instances of different nerve types or sensory receptor types: vision, hearing, olfaction, taste, and touch. These all interact in different ways with the external environment. Vision detects light. Hearing detects vibration in the air. Smell detects chemicals in the air. Taste detects chemicals in the mouth. Touch detects mechanical interactions like pressure and temperature, but also pain. There is, however, another class of sensory receptors that pertain to interoception. For example, baroreceptors are receptors inside blood vessels that measure the pressure exerted on the vessel walls. Different kinds of these receptors exist that register internal bodily states. This category is interoception. Again, the way we usually infer information about external reality is by using different senses and looking for ways in which our perceptions overlap. Hearing and vision, for example, are especially useful for describing objective phenomena because light and sound both travel very fast through the shared external space we inhabit. When you hear a sound like a bark, that is an auditory sensory impression. You can then turn your head and look, see that it is a dog, and visually confirm the sound with a visible source. Because of this overlap, we talk about it as an objectively real thing. Because these senses are so useful for communicating external information, this is also why screens, such as those on a phone or laptop you might be watching this video on, and speakers or earbuds are such effective technologies. They transmit visual and auditory information easily. All 5 external senses can be used in different combinations to check how much they overlap in order to talk about external reality. Take popcorn as an example. You can see it, you can hear it popping. You can smell it, you can touch it, pick it up, you can taste it, and it might be salty or sweet. All 5 senses are involved in perceiving something like popcorn. Here is a table showing how the different senses overlap. Some can be used to cross-check each other, shown in green. Some cannot, shown in red. Others can only sometimes be cross-checked, such as interoception. For example, if you have a wound, you can look at it and see the wound, and you can also feel the pain. Another person can only see the wound and cannot feel the pain. That is why this square is colored yellow. It is only sometimes capable of being cross-checked with other senses. The way we usually talk about external reality is that different people have their own sensory impressions of the world. Here you can see 3 circles, A, B, and C, representing 3 different people and their sensory perceptions. Some of these perceptions overlap. If they overlap enough, people can talk about them using shared sensory words, and this is what we call an object. This kind of social cross-checking is very important, not only in the scientific method, where reproducibility requires that different experiments find the same overlapping effect, but also in everyday contexts. For example, a schizophrenic person can have a service dog that helps them identify hallucinations by greeting people who enter the room.
What? Luna, greet. Greet.
Having hallucinations. My dog is trained to greet people. If she doesn't, then I know they aren't real.
When the person asks the dog to greet someone, and the dog does not do so, the schizophrenic person can know that it is a hallucination, because the dog does not see anyone there, while the person does. This shows how cross-checking can be used to determine whether something is objectively real or only subjectively perceived. Another example is this. Imagine person A is a patient who goes to a doctor, represented by circle B. The patient has a stomachache, which person A can feel. When person A points at their stomach, both person A and person B can see the stomach, but only person A feels the pain, and person B does not. In order to get information about whether there is pain, person B, the doctor, has to ask the patient where they feel it and how intense it is. There are different charts where people can color regions of their body to indicate the location and intensity of pain. This is often done using a spectrum from 0 to 10, with 0 meaning no pain and 10 meaning the worst pain imaginable. But there are also other ways we talk about these kinds of interoceptive perceptions using much less objective measuring tools. For example, we talk about feeling butterflies in the stomach when something exciting is happening or when someone is romantically interested. We talk about having a gut feeling, where the gut seems to register something independently of deliberate reasoning. Another example is feeling a lump in the throat when experiencing heavy emotions, where the throat tightens and it becomes hard to speak. All of these kinds of perceptions are known as qualia, which refers to the felt, subjective experience of what it is like to have a certain sensation or mental state. A way to illustrate this is with a thought experiment known as Mary's Room. Imagine a woman named Mary who has grown up her entire life in a black and white room and has never seen color. However, everything she has ever done is study all there is to know about color, the neuroscience of color, the physics of color, all of it. She is a complete expert on color, except that she has never seen it herself. The question is whether she would know what, for example, red looks like. Would she be able to recognize red or distinguish it from green the first time she sees it? The usual intuition is that she would not, or that there is still something more besides all the physical facts and objectively measurable information about color, namely what color looks like, what color feels like. We do not need to reenact any unethical experiments by locking people in black and white rooms to explore this idea, because there are real-world analogues. For example, people who are colorblind, depending on which cones or rods are missing or impaired, have never experienced certain colors that others can see. Another example is people who have lost sensation in parts of their body, either through injury or from birth. Paraplegia involves numbness in the lower half of the body. Hemiplegia involves numbness on one side of the body along its entire length. Tetraplegia involves numbness in almost the entire body up to the head. Depending on whether someone has had this condition their entire life or acquired it later, they may not be able to know what it feels like to have feet or to experience sexual sensations or other kinds of bodily perceptions in those numb areas. So, tying all of this together and returning to the original point about chakras, I think we can analyze the concept of chakras through the lens of these analogous phenomena. The word chakra in Sanskrit means wheel. Although chakras have not been adopted into modern science, there have been various attempts to speculate about their possible biological correlates. For example, Charles Leadbeater published a book in 1927 in which he discussed chakras through a Western medical lens. He hypothesized that chakras correspond to nerve plexuses along the body and that they function as ways of denoting the convergence or knots of many neurons in particular regions, often associated with specific organs. We can extend this idea by noting that the circulatory system also passes through these same regions. Along the spine at different heights, there are branching nerves as well as branching blood vessels. Because blood is constantly circulating and nerves are continuously sending and receiving signals, these overlapping processes, such as baroreceptors in blood vessels sending information about pressure and flow in specific organs, can give rise to the metaphorical experience of a spinning wheel or an energetic center inside the body. This helps explain why Indian traditions emphasize these phenomena so strongly. They place a heavy focus on interoception, for example through meditation. One way to understand this through a Western framework is Freud's iceberg model of the unconscious. In this model, conscious awareness, the thoughts, perceptions, and sense of self we usually identify with, is the small tip of the iceberg above the water. Below the surface lie deeper and deeper layers of unconscious material, including stored information, bodily signals, and more primitive impulses. A way to visualize the shifting of attention that happens in meditation, but also in everyday life, when an unconscious stimulus suddenly becomes salient and enters awareness, is the following. For example, your leg might suddenly start hurting, and you become very aware of your leg, whereas before you were not paying attention to it at all. In Freud's iceberg metaphor, this is analogous to the iceberg shifting, where parts that were previously underwater rise above the surface and enter awareness. This metaphor is evocative, but it is not a very formal description of how attention and introspection of bodily sensations actually work. Another way to think about this is in terms of the neural connections between the brain and the nerves throughout the body. Here you see the city of Willemstad in the Netherlands. It was originally designed as a fortress, with a moat running around it and various defensive towers and positions arranged in a roughly hexagonal shape. The people inside the city were protected by the moat, which insulated them, but they sometimes needed to enter or exit the city. That was only possible through a small number of bridges, which were gated and guarded so that entry was restricted. In mathematics, there is a way to represent this kind of structure called a Markov blanket. For example, when Google Maps models a route through a city like this, it has to take these constraints into account. The moat functions as a Markov blanket because it insulates the city and creates the situation that, if you are standing across the moat and want to enter the city at that point, you cannot. You have to travel to one of the bridges to get in. This changes the possible routes. If you are driving a car, you may need to take a much longer path than you would if you could simply cross the moat directly. Functionally, something similar exists in the nervous system. There is a distinction between the central nervous system, which includes the brain and spinal cord, and the rest of the nervous system, called the peripheral nervous system, which extends throughout the body. The peripheral nervous system includes both consciously controllable functions, such as muscles, and unconscious processes, such as intestinal activity involved in digestion. In a similar way to the city and its moat, there is a functional boundary between the central and peripheral nervous systems. Information and impulses can cross this boundary, but only through relatively narrow channels. The size of this funnel can effectively be opened or closed, which determines which bodily signals enter awareness and which remain in the background. This is another way of describing how parts of the iceberg rise above the surface. Within the peripheral nervous system, there is also the autonomic nervous system. This governs the automatic dialogue between organs and nerves. It is broadly divided into two modes. The parasympathetic mode dominates during relaxation. When food can be digested, there are no immediate threats, and there is no need to hunt or flee. The sympathetic mode dominates during fight or flight situations when more energy needs to be mobilized, metabolism shifts, and different bodily functions are prioritized. All of this happens through an automatic switching system, so we do not need to consciously manage it. This is why it is called autonomic, meaning self-governing. One way I personally came to recognize the sensation associated with chakras as originating in the peripheral nervous system was during meditation. I was trying to empty my mind, but I became aware of my breath as a slow waveform moving up and down. At the same time, I perceived my heart rate, which had a faster rhythm than my breathing. Together, this formed a kind of combined waveform of breathing and heartbeat. At first, I became annoyed by this, because I thought I was supposed to empty my mind completely during meditation. But then I realized that this was actually interesting, and that paying attention to it could itself be a focus. The lungs usually function automatically, but we also have the ability to consciously control them. They sit right at the boundary of awareness. They can remain below it or be deliberately pulled into it. The heart rate, by contrast, is much harder to control directly. You cannot simply decide to slow or speed it up. You can only influence it indirectly, for example, through movement or exercise. This is why breathing plays such a central role in meditation. It makes us aware of rhythms and cycles that usually run in the background. By focusing on the breath and its fluctuations, awareness is gently shifted into the body. If we accept the analogy of pain maps, where pain is visualized in certain regions, even though the body does not literally glow red where it hurts, we can treat chakras in the same way. If chakras function analogously to nerve plexuses and circulatory clusters, then they can be understood as metaphors rather than literal objects. We should not expect to find glowing orbs inside the body. These images are representations of felt experiences that cannot be directly seen. In many New Age traditions, each chakra is associated with physiological functions, aspects of consciousness, and classical elements. These systems do not correspond exactly to ancient Indian models, but are composites drawn from multiple traditions. Chakras are said to vitalize the physical body and are associated with interactions on physical, emotional, and mental levels. They are considered loci of life energy, spiritual energy, or prana, also known as qi in Chinese, or breath. This energy is thought to flow among the chakras along pathways called nadi. The function of the chakras is to spin and draw in this energy in order to keep the spiritual, mental, emotional, and physical health of the body in balance. If we translate this into biomedical terms, we could say that this refers to metabolic processes, such as the movement of nutrients, oxygen, and ATP for energy synthesis throughout the body. All of this happens along physical pathways, and the terms prana and nadi can be understood as referring to the subjective experience of having a body in which these processes are taking place. The lowest chakra is called Muladhara, and it is located at the base of the spine. It is associated with the element of earth. The word chakra here is often glossed as root. This chakra is associated with joy, natural pleasure, control of passion, blissfulness, and concentration. It can also represent different kinds of longing, spiritual longing, psychological longing, or physical longing. When this chakra is imbalanced, it may manifest in various ways, such as lower back pain, fatigue, or digestive issues. Emotionally, people may feel anxious, fearful, or disconnected. Fundamentally, this chakra is associated with basic survival and existence. Evolutionarily, it corresponds to something very old. Mechanisms that maintain homeostasis, keep the organism alive, ensure sufficient nutrient intake, and promote a sense of safety rather than danger. What is often said about this lowest chakra is that at the base of the spine there is a coiled snake, called Kundalini in Sanskrit. In its usual state, it rests at the bottom of the spine, but through meditation and practice, it can be awakened and is then said to climb upward along the spine. When we try to translate this into Western biomedical terms, it is interesting to note that a snake is essentially a long spine with a head. In a certain sense, the part of our nervous system consisting of the spinal cord and basic motor functions resembles a snake embedded within the body. The metaphor of a coiled snake at the bottom as stored potential energy that can shoot upward fits this quite well. India may have used this metaphor partly because of snake charmers who make snakes rise and move out of baskets. But using the earlier analogies, this can also be understood as spinal awareness entering perception and presenting itself to consciousness as a snake-like motion rising upward. Another reason for the snake metaphor may lie even deeper in evolutionary history. Many animals have an instinctive fear response to snake-like shapes. Cats, for example, will reflexively jump away when they suddenly encounter something elongated that resembles a snake. People sometimes place cucumbers next to cats to trigger this reaction, and the response is immediate and automatic. The cat does not have time to consciously identify the object. The body reacts instantly. Ancestors with this reflex had a higher survival rate than those who did not. Somewhere deep in the brain, there appears to be an imprint of elongated snake-like forms as potentially dangerous. Our closest relatives, apes, show a related pattern. They have an instinctual recognition of snakes, but they need to learn to fear them. This is why zookeepers sometimes have to teach young orangutans that snakes are dangerous.
There's something not right. Penty reassures the youngsters. But Chinta has a suspicion as to what this might be. Bravely, she takes the lead. Four-year-old Otan arrives late to the Fear Fest. And he thinks this sack looks good. Just in time, Technici Muliono comes to the rescue and beats his special rubber teaching aid to death. The Group 2 kids have never had snake awareness class before, and today they responded perfectly. In primates, recognition of snakes is instinctive, but fear of snakes is learned. Which is why Muliono tours this lesson around the forest school groups. It's a lesson they won't forget.
The idea that the snake is a very old archetype imprinted in the brain is further supported by its central role in religions around the world. Australian Aboriginal cultures speak of the rainbow serpent, a creator being that governs reality itself and whose disturbance brings chaos. In ancient Egypt, there were cosmic snakes such as Apep, who threatened to devour the entire cosmos, until a cat deity, often identified as Mafdet or Bast, defeated him. Egyptian symbolism is also filled with cobra imagery, such as the uraeus, representing nobility and divine authority. There is also the symbol of the snake eating its own tail. The oldest known example appears in an Egyptian relief and is later known by the Greek name Ouroboros. This symbol represents the self-sustaining, cyclical nature of reality and time. This primal cosmic snake appears in many other traditions as well. In Norse mythology, the Midgard serpent, Jörmungandr, encircles the world in the ocean's abyss and bites its own tail. In the Old Testament, in the book of Genesis, the Garden of Eden contains the tree of life and a snake entwined around it. The snake convinces Eve to eat the fruit, after which she becomes aware of her nakedness and gains a more reflective, self-conscious awareness, moving away from a purely instinctive or childlike state. Later in the Old Testament, snakes also appear as symbols of magic and divine power. Moses asks God for a sign, and his staff turns into a snake and then back into a staff. This relationship between staffs and snakes is ancient. One of the oldest examples is Ningish Zida, a Mesopotamian deity associated with serpents and sometimes described as an ancestor of Gilgamesh, who, according to the Epic of Gilgamesh, dives to the bottom of the waters to retrieve the plant of life. The Sumerian deity Ningish-Sida is accompanied by 2 griffins, Mushusu. This is the oldest known image of 2 snakes coiling around an axial rod, dating from before 2,000 years before Christ. The rod of the caduceus, meaning the herald's wand or staff, is the staff carried by Hermes in Greek mythology and later by Hermes Trismegistus in Greco-Egyptian traditions. The same staff was carried by other heralds such as Iris, the messenger of Hera. The short staff is entwined by 2 serpents and is sometimes surmounted by wings. In honor of Asclepius, a particular type of non-venomous rat snake was often used in healing rituals. These snakes, known as Asclepian snakes, crawled freely on the floors of dormitories where the sick and injured slept. They were introduced at the founding of each new temple of Asclepius throughout the classical world. The serpent and the staff appear to have originally been separate symbols that were combined at some point in the development of the Asclepian cult. The significance of the serpent has been interpreted in many ways. Sometimes the shedding of the skin and renewal is emphasized, symbolizing rejuvenation. Other interpretations focus on the serpent as a symbol that unites and expresses the dual nature of the physician's work, dealing with life and death, sickness and health. The ambiguity of the serpent as a symbol and the contradictions it represents reflect the ambiguity of drugs themselves, which can heal or harm. This is captured in the ancient Greek term pharmakon, which meant drug, medicine, and poison. The python was a serpent sometimes represented as a dragon living at the center of the earth, believed by the ancient Greeks to be located at Delphi. The Greeks considered Delphi to be the center of the world, marked by a stone called the omphalos, meaning navel, which Python guarded. Python later became the chthonic enemy of the Olympian god Apollo, who slew it and took over its oracle. The Lernaean Hydra is another serpent or dragon figure, guarding sacred space and eventually defeated by Heracles as one of his labors. In Mesoamerica, there is a common deity among the Aztec and Maya known as Quetzalcoatl, meaning the feathered serpent. This connects to the concept of the vision serpent, a central figure in pre-Columbian Maya mythology and an important social and religious symbol. Maya mythology describes serpents as vehicles by which celestial bodies, such as the sun and stars, traverse the heavens. The shedding of their skin made them symbols of rebirth and renewal. During Maya bloodletting rituals, participants experienced visions in which they communicated with ancestors or gods. These visions often took the form of a giant serpent, which functioned as a gateway to the spirit realm. The ancestor or deity being contacted was depicted as emerging from the serpent's mouth. The vision serpent thus became the means by which gods or ancestors manifested themselves to the Maya. It functioned as a direct link between the spirit realm and the physical world. This concept reaches back to earlier Maya cosmology and lies at the center of the world as they conceived it. It forms the central axis atop the world tree. The world tree and the vision serpent, often represented through the figure of the king, together create the axis that connects the spiritual and earthly planes. Through ritual, the king could bring this axis into existence within temples, creating a doorway to the spiritual world and with it, political and religious power. Among Amazonian cultures, the cosmic serpent is associated with Mother Ayahuasca, the spirit of the Banisteriopsis capi vine, which itself resembles a snake. During visions induced by the psychoactive compound DMT contained in ayahuasca, people frequently report encounters with cosmic serpents. Snakes also play a major role in Eastern religions. In Hindu and Buddhist traditions, there are the Nagas. One such Naga is Mukhalinda, who protected Shakyamuni Buddha from the elements after his enlightenment. It is said that 6 weeks after Gautama Buddha began meditating under the Bodhi tree, the heavens darkened for 7 days and heavy rains fell. The serpent king Mukhalinda emerged from beneath the earth and sheltered the Buddha with his hood. In Hindu mythology, Lord Vishnu is said to sleep on the cosmic waters on the serpent Shesha. In the Puranas, Shesha holds all the planets of the universe upon his hoods and continually sings the glories of Vishnu. He is often referred to as Ananta Shesha, meaning endless Shesha, and is depicted as a serpent with many heads. Moving higher to the next chakra, we find Svadhisthana, associated with the sexual organs and the element of water. This corresponds to nerves branching toward the reproductive organs, as well as bladder and bowel control. Moving further upward, we reach the Manipura chakra, located around the navel and associated with the element of fire. This relates to digestion, energy, and vitality. A strong Manipura chakra is associated with a sense of fullness, courage, and the energy to face the challenges of the day. When weakened, it may manifest as jealousy, hunger, or a sense of lack or impoverishment. Above this is the Anahata chakra, located around the heart and associated with the element of air. This aligns with experiences such as a racing heart under stress or the sensation of warmth and expansion when in love, as well as the metaphor of a broken heart. These expressions all refer to sensations around the Anahata chakra. Next is the Vishuddha chakra, located at the throat and associated with the element of space. This relates to speech and communication, but also to the thyroid gland, which produces hormones that regulate metabolism. When this chakra is open, one can express emotions, articulate thoughts, and communicate needs. When it is blocked, it may be experienced as a lump in the throat or a difficulty in expressing oneself. Above that is the third eye chakra, known as the Ajna chakra, located between the eyebrows and associated with light and darkness. The idea of the third eye chakra has long been doubted by skeptical materialists and empiricist scientists, largely because it cannot be directly observed and because Western science places relatively little emphasis on interoception, on feeling into one's own body, especially in regions like the space between the eyebrows. As a result, it is generally not recognized as something real within mainstream Western science. However, there is a plausible biological and evolutionary origin for this center of awareness associated with light and darkness. A PhD student from Yale, Kelsey Jenkins, explored this topic in her doctoral research.
I want to start off talking about the third eye because it might be a familiar concept to some of you in the audience. The idea of this sort of invisible third eye is a pretty mystical concept in several Eastern religions, including Hinduism and Buddhism and Taoism, among others. And while there are nuances and differences in the function of this third eye between these different religions, all imply that this organ provides a type of perception beyond what our quote-unquote regular eyes are ordinarily capable of seeing. So here you see the Hindu god Shiva on the left with a laterally oriented third eye, symbolizing knowledge and the detection of evil. On the right, you see Buddha, who's depicted here with a third eye, sometimes regarded as the eye of consciousness or the eye of wisdom. Now, this idea even carried on into more recent Western religious movements. This is Helena Blavatsky, a Ukrainian-born mystic who is the founder of the religion of Theosophy in the United States, where she rose to fame as a spiritualist and a psychic medium. Having traveled the world and dabbled in Eastern religions, she was very captured by the idea of a third eye, but found it to be more deeply entrenched in her own human biology. Helena, as well as some other founders of Theosophy, believed that the third eye actually referred to the pineal gland, what she thought was a partially dormant gland that sits between the two hemispheres of the brain. She claimed that the pineal gland was truly an atrophied eye, and it was far more connected to the soul and the spirit than any other physiological senses of man. Should we sort of reactivate this organ, in her opinion, we could tap into abilities within ourselves, such as telepathy. Now, the reason Helena rooted this idea in biology is because she knew a particular fun fact about lizards. Many lizards, as well as their close cousins, the New Zealand tuatara, possess what some might think of as an unusual feature on the top of their heads. All of these lizards are different species, but they have something really interesting in common, where you see these arrows and these circles. There's a very special scale located just behind the eyes on the forehead, if you will, what covers as a rudimentary eye. Now, this is an example from a fence lizard pictured on the right. If we were to dissect a lizard and look at a cross-section of the skull, which you see on the left here, right where that scale is, we'd see an organ that is in every way an actual eye. Just like the two eyes on your own face, this pineal eye possesses a retina, it possesses a lens, cornea. The only thing it's missing is the iris, so that's the part of your eye that contracts when it, a flashlight shines on your face or you enter into the sunshine. It's meant to restrict the amount of light entering into your eye at any given time. So it doesn't have that, but it has literally every other component of a regular eye. And this eye is closely associated with functions of that hidden pineal gland that we observe in humans, including things like growth and metabolism. Now, what I think is cool, but maybe it's obvious to you, is that there's evidence of this pineal eye even if you just have the skull. On the right, you see the skull of the New Zealand tuatara, scientific name is Sphenodon punctatus, and you'll see where this arrow appears, there's a hole. We call that hole a foramen, and it's sitting right in the middle of the skull between two bones called the parietals. That's why this organ is also sometimes called the parietal eye, so you'll hear me switch back and forth between pineal eye and parietal eye, but they're the same thing. Now, just for comparison, I also have the skull of a wolf here, which doesn't have that parietal opening, and it does not have a parietal eye. Like all other mammals, it just has that pineal gland tucked within the brain. One hypothesis for this is, mammals are endothermic or warm-blooded. Because of this, they're able to regulate their metabolism and other body processes without the use of the parietal eye to tell them to go outside and bask in the sunshine. Now, similarly, crocodilians and turtles also lack this structure, though we don't think of them as endothermic animals. We have this idea from the fossil record, though, that their ancestors might have been. And as a result, these animals lost their parietal eyes at some point in their evolution and never evolved them back. But what does this organ actually do? There's been a slew of hypotheses and experiments over the years, and I admit this is an area that needs way more research, but we do have a rough idea that it has something to do with the ability to regulate body temperature in ectothermic or cold-blooded tetrapods. So imagine your typical lizard, it basks in the sun, which in turn affects all of the lizard's other body processes. This particularly warm time spent in the sun aids in metabolism temporarily, it aids in digestion, and it helps to produce the hormones that the typical lizard needs in its typical lizard life cycle. When the lizard is done basking, maybe he's overdone it a little bit, the parietal eye signals to him that it's time to go back in the shade. So the pineal eye, this parietal eye, isn't just about detecting light, it's an eye keeping watch on all the body's most important functions and processes, and it uses this as a signal to the lizard about those processes.
The core idea is that early vertebrates possessed a light-detecting organ, sometimes referred to as a parietal or third eye, that allowed them to sense ambient light levels and distinguish day from night. This information was crucial for regulating body temperature in cold-blooded animals. As evolution progressed and animals became warm-blooded, this function became less necessary for thermoregulation. However, the central system that coordinated circadian rhythms, the switching between sleep and wakefulness, remained. Instead of being driven directly by a light-sensitive organ on the top of the head, it became regulated through light input from the eyes. This regulatory function is now associated with the pineal gland and the broader circadian system.
The pineal organ of the diencephalon is characteristic of all vertebrate brains. It is typically a single bulbous structure, which can easily be identified by being located between the tectum or superior colliculi of the midbrain and the cerebrum, but it does vary. It can be associated with another parietal eye with even a simple lens-like structure and be together associated in this pineal complex, but in some fish and amphibians there can be parapineal structures as well. The pineal structure may be paired. So for simplicity's sake, I'll refer to a simple pineal organ, but it can be more complex and have associated structures in lower vertebrates. In lower vertebrates, the pineal gland not only produces melatonin, but also perceives light. And the light which is perceived by the pineal gland is then the external signal which regulates the release of melatonin by the pineal gland. And so thus it is on the dorsal surface of the diencephalon where it can perceive light. And once the first osteichthyans developed parietal bones, there was an opening between the two parietal bones known as the pineal foramen. This opening allowed light through the skin of the epidermis of the scalp, which then went through the pineal foramen and then gave the pineal organ information about whether it was day or night and the length of the day. This pineal foramen is present in the skull roof of the first osteichthyan fish, but then throughout the early Osteichthyan fish and present in many today. It was present in the Sarcopterygian fish, which were the ancestors of tetrapods. It was present in the first amphibians. It was present in the first reptiles, and in many reptiles today, such as lizards and the tuatara. It was present in the earliest synapsid reptiles, and even through the group the therapsids. It was in the cynodont reptiles, the direct ancestors of mammals, that the pineal foramen was lost. Mammals today still retain a pineal gland in the diencephalon of their brain on its dorsal surface, including humans, but it is no longer under a pineal foramen, and the expansion of the cerebrum has covered it, so it was no longer capable of perceiving light. However, it does still produce melatonin triggered by light, but now the light stimuli come from the eyes to the hypothalamus, which then relays the information to the superior cervical ganglion, which then regulates signals the pineal gland. So the pineal gland still does release melatonin in response to the light-dark cycle, but it is no longer directly perceiving this light, but being relayed light from the eyes through the hypothalamus.
This may help explain why philosophers such as René Descartes identified the pineal gland as the seat of the soul. This idea is often mocked as an outdated attempt to connect mind and body, but when examined more closely, it becomes more intelligible. If the pineal gland plays a central role in regulating sleep, wakefulness, and states of consciousness, essentially the same system an anesthesiologist manipulates to turn consciousness on or off, then it occupies a pivotal position in the transition between awareness and unconsciousness. The pineal gland also functions as part of the internal biological clock, relaying information about night and day. During sleep, consciousness does not simply disappear, it transforms. In dreams, one experiences vivid realities governed by entirely different rules of physics and logic. The switching between waking interaction with sensory input and internally generated world models may not be fully governed by the pineal gland, but it is plausibly steered by it. From this perspective, the idea that it turns consciousness on and off no longer seems entirely absurd. At the top of the spine and the crown of the head is the final chakra, the Sahasrara, associated with space, time, and non-dual or transcendent awareness. My speculation here is that this association emerges from the type of information processed in the upper regions of the brain. These areas integrate spatial relationships between body parts, visual processing, linguistic interpretation, and higher-order modeling of reality. Together, they generate a coherent simulation of the world and of oneself within it. If this simulation process itself becomes fully conscious, something interesting happens. One may realize that awareness is not something passively receiving an external world, but something actively constructing it. This is analogous to becoming lucid in a dream, or recognizing that one is hallucinating. In such moments, the distinction between subject and object can collapse. There is no longer a clear you observing a world. There is simply the mind generating experience. This may explain why the Sahasrara chakra is associated with non-dual awareness. This framework also connects to broader ideas in evolutionary psychology and brain evolution. The progression of chakras loosely mirrors the evolutionary layering of the nervous system, from reptilian impulse-driven circuits to mammalian emotional and memory systems to the human neocortex, with its capacity for abstraction, imagination, language, and reasoning. The chakra ladder can be seen as a symbolic map of increasingly complex modes of regulation and awareness layered onto one another over evolutionary time. I had been developing these speculations independently for some time, but later encountered the work of the Australian philosopher Aidan Lyon, a former student of David Chalmers. Lyon has written a book on psychedelic philosophy and experience, published by Oxford University Press, and he recently conducted what may be the first neuroscientific research on chakra meditation within Western academic literature. He also organised several events in Amsterdam at the Embassy of the Free Mind, 2 of which I was fortunate enough to attend. These discussions were both enjoyable and stimulating, and they left me with many further ideas, both about what was said and about what remained unsaid. This video is my attempt to synthesize those ideas into a coherent narrative. This concludes the discussion for now. I have many more ideas for future videos that explore similar intersections between neuroscience, philosophy, mythology, and consciousness. If this kind of interdisciplinary exploration resonates with you, more will follow in the coming months. I would greatly appreciate it if you would subscribe in case you want to be notified when I upload new video essays. Until then, have a nice day.